They called her old-school navigation methods Stone Age techniques and laughed when Chief Master Sergeant Rebecca Compass Rose Martinez insisted on teaching celestial navigation to younger aircrew. But when a squadron of F-22 Raptors vanished in an Arctic storm that disabled all satellite systems, this 48-year-old loadmaster was about to prove that a paper chart and magnetic compass could accomplish what $20 million of GPS technology could not. What happened next would silence every skeptic, expose institutional failures that had endangered American lives, and demonstrate that the most dangerous navigator in the sky was the one they'd all written off as hopelessly outdated. The morning frost clung to the tarmac at McChord Air Force Base in Washington as Rebecca Martinez completed her pre-flight inspection of the massive C-17 Globemaster III that had been her operational home for the past 14 months. The aircraft's gray metal skin bore the subtle scars of countless missions across 6 continents, each rivet and panel telling stories of humanitarian relief operations, combat supply runs, and strategic airlift missions that had taken her from the deserts of Iraq to the mountains of Afghanistan and beyond. Her weathered hands moved across the aircraft's exterior with the practiced precision of someone who understood that attention to detail at ground level determined survival at 30,000 feet. Every inspection plate, every hydraulic line, every surface that could mean the difference between mission success and catastrophic failure received her complete attention. At 48 years old, Rebecca possessed more actual flight hours in heavy transport aircraft than most pilots accumulated in entire careers, with 26 years of military service that had established her as one of the Air Force's most experienced and capable loadmasters. The C-17 Globemaster represented the pinnacle of strategic airlift capability, capable of transporting everything from main battle tanks to entire field hospitals across intercontinental distances. Its advanced avionics suite included GPS navigation systems, satellite communication equipment, and computerized flight management systems that could calculate optimal routes and fuel consumption with mathematical precision that exceeded human capability. Yet Rebecca had learned to operate this technological marvel using navigation techniques that predated satellite technology by decades. Her career had begun during an era when military aircrew relied on dead reckoning, celestial navigation, and magnetic compass headings to guide aircraft across vast distances without electronic assistance. She had mastered the art of plotting courses using paper charts, calculating wind drift corrections manually, and determining aircraft position through landmark recognition and astronomical observation. These skills had proven invaluable during combat operations where electronic warfare could disable satellite systems and force aircrew to rely on fundamental navigation principles that required no external technology. The flight operations building buzzed with the controlled activity of a typical morning briefing cycle as aircrews prepared for the day's missions. Rebecca made her way through corridors lined with tactical displays showing aircraft positions, weather patterns, and mission status updates from around the globe. The walls displayed photographs of previous operations, deployment ceremonies, and recognition events that chronicled the squadron's proud history of operational excellence across multiple conflicts and humanitarian crises. Captain Jennifer Walsh, the aircraft commander assigned to Rebecca's crew, emerged from the mission planning room carrying a thick folder of flight documents and weather reports. At 32 years old, Walsh represented the new generation of military pilots who had learned to fly using advanced navigation systems and computer-assisted flight planning tools. Her training had emphasized integration with satellite-based navigation systems, automated route optimization, and digital communication protocols that allowed real-time coordination with command centers anywhere in the world. "Morning, Chief," Walsh greeted Rebecca with the professional courtesy that characterized working relationships in military aviation. "We've got a standard logistics run to Elmendorf today, then continuing to Thule Air Base for equipment delivery. Weather looks challenging over the Arctic route, but our GPS systems should handle navigation without any complications." Rebecca studied the weather briefing materials that Walsh shared, noting atmospheric conditions and electromagnetic interference patterns that her experience suggested could create significant challenges for satellite-dependent navigation systems. The meteorological data showed solar activity levels that historically had caused GPS signal degradation, particularly in polar regions where satellite coverage was naturally limited by orbital mechanics. "Captain, I'm seeing some concerning indicators in the space weather forecast," Rebecca observed, pointing to specific data points that highlighted elevated solar radiation levels. These electromagnetic conditions could affect GPS reliability over the Arctic route. I recommend we prepare backup navigation procedures using conventional methods in case we lose satellite coverage. Walsh glanced at the weather data briefly before dismissing Rebecca's concerns with the confidence of someone who had never experienced navigation system failures during critical flight operations. Chief, our navigation systems are designed to function in far more challenging electromagnetic environments than anything natural solar activity can produce. The GPS constellation includes multiple backup satellites and error correction algorithms that maintain accuracy even during solar storms. The conversation was interrupted by the arrival of Technical Sergeant David Kim, the aircraft's flight engineer, and Staff Sergeant Maria Santos, the second loadmaster assigned to their crew. Both represented the younger generation of aircrew who had received their training entirely on modern aircraft equipped with advanced electronic systems. Their experience with manual navigation techniques was limited to brief academic exposure during initial training programs that emphasized technological proficiency over traditional skills. Chief Martinez is worried about GPS failures again, Walsh explained to the arriving crew members with barely concealed amusement. She thinks we should prepare paper charts and compass headings like we're flying a World War II bomber across the Pacific. Kim laughed while reviewing his electronic checklist on a tablet computer that contained more navigation capability than entire aircraft had possessed during earlier decades of military aviation. Chief, my tablet has more backup navigation systems than most commercial airlines use for transatlantic flights. Even if GPS fails, we have inertial navigation, VOR stations, and TACON systems that can guide us anywhere we need to go. Rebecca continued her preparation despite the dismissive attitudes of her younger colleagues, pulling out paper charts and plotting primary and alternate routes using traditional navigation techniques. Her manual calculations included wind drift corrections, fuel consumption estimates, and waypoint coordinates that she had determined using latitude and longitude references rather than GPS coordinates. The process required mathematical skills and geographical knowledge that younger aircrew had never needed to develop given the availability of automated navigation systems. Chief, you're wasting time with those ancient charts, Santos commented while programming waypoints into the aircraft's digital navigation system. Our flight management computer can calculate optimal routes automatically and adjust for weather conditions in real time. Why would anyone use manual navigation when computers can do the work faster and more accurately? The question reflected a fundamental philosophical divide that had emerged in military aviation between those who understood traditional navigation principles and those who relied entirely on technological systems. Rebecca's generation had learned to navigate by understanding geographical relationships, atmospheric conditions, and mathematical principles that remain constant regardless of technological availability. Younger aircrew had learned to operate sophisticated systems without necessarily understanding the underlying principles that made navigation possible. Major Patricia Coleman, the Squadron Operations Officer, joined the briefing to review mission parameters and coordinate timing with other aircraft operations scheduled throughout the day. Coleman represented the institutional bias toward technological solutions that had shaped Air Force training and operational procedures for the past decade. Her background included extensive experience with satellite communication systems and digital mission planning tools, but limited exposure to manual navigation techniques. Martinez, I see you're still using paper charts for mission planning, Coleman observed with the tone of someone addressing an outdated practice that should have been abandoned years earlier. Our flight planning software provides more accurate navigation data and real-time updates that paper charts simply cannot match. Perhaps it's time to adapt to modern navigation methods. Rebecca looked up from her charts, where she had been plotting alternate routes and calculating fuel requirements for various contingency scenarios. Major, these charts provide geographic reference information that remains accurate regardless of satellite availability. If our electronic systems experience failures, manual navigation could be the difference between completing the mission and becoming lost over hostile territory. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. Coleman's expression suggested she was dealing with an employee who refused to embrace necessary modernization rather than a veteran who possessed critical backup skills. Chief Martinez, our aircraft are equipped with multiple redundant navigation systems specifically designed to prevent the kind of failures you're concerned about. The probability of simultaneous GPS, inertial navigation, and communication system failures is essentially zero under normal operating conditions. The phrase normal operating conditions carried implicit assumptions about technological reliability that Rebecca's combat experience had taught her to question. She had flown missions where electronic warfare had disabled satellite systems, electromagnetic interference had corrupted navigation data, and equipment failures had forced aircrew to rely on fundamental flying skills that automated systems could not provide. Her preparation for such contingencies was viewed as excessive caution rather than professional competence. Lieutenant Colonel Michael Torres, the squadron commander, appeared in the briefing room to review the day's mission schedule and address any operational concerns that required command attention. Torres had built his career during the transition from analog to digital aviation systems, but his advancement had come through administrative competence rather than operational flying experience. His understanding of navigation challenges was largely theoretical, based on technical manuals rather than practical experience with system failures under adverse conditions. Chief Martinez, Major Coleman has expressed concerns about your continued reliance on manual navigation procedures, Torres announced, consulting his electronic tablet where he maintained notes about personnel performance and training requirements. We need all aircrew current on modern navigation systems to maintain operational effectiveness. Perhaps additional training on advanced GPS systems would improve your mission readiness. The suggestion carried the clear implication that Rebecca's navigation skills were deficient rather than complementary to modern systems. Her decades of experience successfully navigating aircraft across global distances using traditional techniques were being characterized as evidence of her inability to adapt to contemporary operational requirements. The institutional pressure to abandon manual navigation skills reflected broader policy decisions that prioritized technological dependence over traditional aviation expertise. Rebecca's response was measured and professional despite the obvious dismissal of her capabilities. "Sir, I'm fully qualified on all navigation systems installed in this aircraft. My manual navigation procedures provide backup capability that could prove essential if electronic systems experience failures during critical mission phases. I maintain these skills to ensure mission completion under any conditions we might encounter." Torres closed his tablet with the finality of someone whose decision had already been made before the conversation began. "Chief, modern aircraft systems are designed with sufficient redundancy to handle any reasonable failure scenarios. Your time would be better spent mastering advanced features of our current navigation equipment rather than maintaining outdated procedures that have been superseded by superior technology." The meeting concluded with Rebecca once again isolated from her colleagues' confidence in technological solutions, while privately maintaining her conviction that traditional navigation skills remained essential for operational safety. As the crew dispersed to complete pre-flight preparations, she continued plotting manual navigation routes and calculating backup procedures that her experience suggested they might need during their mission to the Arctic regions, where GPS coverage was naturally limited and electromagnetic interference posed genuine threats to satellite-dependent systems. Her aircraft logbook contained entries documenting successful missions completed using manual navigation when electronic systems had failed or proved inadequate for specific operational requirements. These experiences had taught her that technological superiority meant nothing when the technology stopped working, leaving aircrew dependent on fundamental skills that younger personnel had never needed to develop. The Arctic mission ahead would test whether institutional faith in modern navigation systems was justified, or whether traditional skills might once again prove their enduring value. The revolution in military aviation navigation had arrived at McChord Air Force Base, with the installation of the Integrated Navigation and Communication System, a technological marvel that represented the cutting edge of satellite-dependent flight operations. The INCS combined GPS positioning, satellite communication, and automated flight planning into a single interface that promised to eliminate human error from navigation calculations, while providing real-time updates from command centers around the world. Captain Jennifer Walsh had been among the first pilots selected for advanced INCS training at the Air Force's premier navigation school at Randolph Air Force Base in Texas. The 6-month program had immersed her in the theoretical and practical applications of satellite-based navigation, teaching her to trust computer-generated solutions over traditional piloting instincts. Her graduation certificate hung proudly in her quarters, alongside commendations for achieving the highest scores ever recorded on digital navigation proficiency examinations. The training philosophy at Randolph emphasized technological integration over individual skill development, based on research showing that human pilots made calculation errors that sophisticated computers could eliminate entirely. Students learned to input destination coordinates and weather parameters into automated systems that would generate optimal flight paths, fuel consumption estimates, and timing calculations with mathematical precision that exceeded human capability. The curriculum included minimal instruction on manual navigation techniques, which were dismissed as backup procedures that modern aircrew would never need to employ. Walsh's approach to mission planning reflected this training completely. She relied on the aircraft's flight management computer to calculate routes, determine fuel requirements, and establish communication schedules with air traffic control facilities along their planned route. Her pre-flight briefings focused on verifying that electronic systems were functioning properly rather than developing contingency plans for potential system failures that the training program had assured her were statistically insignificant. Technical Sergeant David Kim represented the new generation of flight engineers who understood aircraft systems through computer interfaces rather than mechanical knowledge. His training had emphasized monitoring electronic displays and responding to automated alerts, rather than developing the intuitive understanding of aircraft behavior that had characterized earlier generations of aircrew. Kim could operate the most sophisticated navigation systems in the Air Force inventory, but his knowledge was limited to the procedures displayed on computer screens rather than the underlying principles that made navigation possible. The flight engineer station in the C-17 resembled a space mission control center more than traditional aircraft equipment. Multiple high-resolution displays showed GPS coordinates, satellite communication status, weather radar imagery, and navigation system performance data in real-time updates that provided unprecedented situational awareness under normal operating conditions. Kim had memorized the procedures for operating each system and troubleshooting common malfunctions. But his training had not included manual calculation methods that could substitute for electronic system failures. Staff Sergeant Maria Santos had learned her loadmaster duties entirely through computer-assisted training programs that simulated mission scenarios using virtual reality technology. Her understanding of aircraft weight and balance calculations, cargo loading procedures, and navigation coordination came from interactions with sophisticated software rather than hands-on experience with physical aircraft systems. Santos could operate advanced cargo management computers that optimized loading configurations automatically, but she had never calculated weight distribution manually using the mathematical formulas that had guided loadmasters for decades. The new generation's confidence in technological solutions was reinforced by impressive performance statistics that demonstrated the superiority of computer-assisted navigation over traditional methods. GPS systems provided accuracy within 3 meters anywhere on Earth, while manual navigation techniques were considered accurate if they achieved positioning within several miles of intended destinations. Satellite communication allowed real-time coordination with command centers that could provide updated weather information, route modifications, and emergency assistance that manual navigation could not access. Major Patricia Coleman had built her reputation by championing the integration of advanced navigation systems throughout the Air Force's transport fleet. Her master's thesis at the Air War College had analyzed the cost savings and safety improvements achieved by replacing manual navigation procedures with automated systems. The research showed that computer-assisted navigation reduced flight time, improved fuel efficiency, and eliminated the human errors that had caused navigation-related accidents in previous decades. Coleman's office displayed awards recognizing her contributions to aviation modernization alongside photographs of her meeting with defense contractors who had developed the navigation systems now standard throughout Air Force operations. Her influence extended beyond McCord Air Force Base to policy decisions that shaped training programs and equipment procurement across the entire military transport community. She viewed resistance to technological adoption as evidence of professional inadequacy rather than legitimate concern about system vulnerabilities. The institutional bias toward modern navigation methods was reflected in performance evaluation criteria that emphasized technological proficiency over traditional aviation skills. Aircrew received high ratings for demonstrating mastery of advanced systems, while receiving lower scores for maintaining manual navigation capabilities that were characterized as unnecessary redundancies. Career advancement required expertise with the latest equipment rather than comprehensive understanding of navigation principles that transcended specific technological implementations. Lieutenant Colonel Michael Torres had risen through the ranks during the period when the Air Force was transitioning from analog to digital navigation systems. His early flying experience had included some exposure to manual navigation techniques, but his command responsibilities had focused on managing budgets and personnel rather than maintaining operational flying skills. Torres understood the institutional pressure to embrace technological solutions while lacking the practical experience that might have taught him to question the reliability of complex electronic systems. The squadron's training program reflected this institutional bias clearly. New aircrew spent months learning to operate sophisticated navigation computers while receiving only minimal instruction on manual navigation techniques. The curriculum treated traditional methods as historical curiosities rather than essential backup skills, based on the assumption that modern systems provided sufficient redundancy to handle any conceivable failure scenarios. Students who expressed interest in learning manual navigation were discouraged from pursuing what instructors characterized as obsolete skills that would never prove operationally relevant. Captain Blake Morrison, a recent addition to the squadron, exemplified the new generation's complete dependence on electronic navigation systems. His pilot training had taken place entirely on aircraft equipped with GPS navigation, and his flight experience included no exposure to manual navigation techniques beyond brief academic discussions during ground school. Morrison could operate the most advanced flight management computers with impressive skill, but he had never calculated a magnetic heading or plotted a course using paper charts and traditional navigation tools. Chief Martinez keeps talking about manual navigation like we're going to be flying around with broken radios and dead GPS satellites, Morrison commented to his fellow pilots during an informal gathering in the squadron ready room. When has anyone ever needed to navigate using a compass and paper charts? Our systems are designed with enough backup capability to handle any realistic failure scenario. The conversation reflected a broader cultural shift within military aviation that valued technological sophistication over traditional flying skills. Younger pilots prided themselves on their ability to maximize the capabilities of advanced aircraft systems while viewing manual techniques as evidence of technological incompetence. They had learned to fly in an environment where computers provided solutions to navigation challenges that previous generations had solved through individual skill and experience. First Lieutenant Sarah Chen had graduated from the Air Force Academy with degrees in computer science and aerospace engineering, bringing theoretical knowledge of navigation systems that exceeded most operational pilots' understanding of the technology they used daily. Her academic background included detailed study of GPS satellite operations, inertial navigation principles, and communication system architecture, but no practical experience with the manual navigation techniques that had guided military aviation for decades before satellite technology became available. Chen's approach to navigation planning involved sophisticated computer modeling that analyzed weather patterns, fuel consumption variables, and route optimization algorithms to determine mathematically optimal flight paths. Her calculations were more precise than any manual navigation could achieve, but they depended entirely on the continued operation of electronic systems that she had never seen fail during her limited operational experience. Her confidence in technological solutions was absolute, because she had never encountered situations where technology proved inadequate. The squadron's senior leadership actively discouraged interest in manual navigation techniques through assignment policies that favored aircrew with advanced technological qualifications over those who maintained traditional skills. Mission opportunities, training slots, and career advancement prospects were consistently allocated to personnel who demonstrated proficiency with the latest equipment rather than those who possessed comprehensive navigation knowledge that included manual techniques. The message was clear. The Air Force valued technological adaptation over traditional aviation expertise. Master Sergeant Robert Hayes, the squadron's senior enlisted advisor, had observed the transition from manual to automated navigation during his 22 years of military service. His early career had included extensive training on traditional navigation techniques, but his current responsibilities focused on managing administrative functions rather than maintaining operational flying currency. Hayes understood both the capabilities and limitations of modern navigation systems, but his voice carried little influence in policy decisions that shaped training priorities and operational procedures. The technological revolution had created a generation of aircrew who possessed unprecedented capability under normal operating conditions, while lacking the fundamental skills that had enabled previous generations to succeed when normal conditions did not exist. Their training had prepared them to maximize the performance of sophisticated systems, without developing the independent problem-solving abilities that became essential when those systems failed or proved inadequate for specific operational challenges. The confidence in technological solutions extended beyond individual aircrew to institutional policies that had eliminated traditional navigation equipment from most aircraft and reduced manual navigation training to brief theoretical discussions during initial qualification programs. The Air Force had made strategic decisions to invest in satellite-dependent systems while abandoning the infrastructure and expertise that had provided backup capability when electronic systems proved unreliable or unavailable. This technological dependence would soon be tested by operational conditions that exceeded the parameters used in computer modeling and system design, revealing whether faith in modern navigation systems was justified or whether traditional skills might still prove essential for mission success. When sophisticated technology encountered the harsh realities of Arctic flying conditions, where satellite coverage was limited and electromagnetic interference posed genuine threats to electronic navigation systems. The marginalization of Rebecca Martinez began subtly, wrapped in the language of operational efficiency and modernization initiatives that appeared reasonable on their surface but systematically excluded her from meaningful mission opportunities. Within 3 weeks of the electromagnetic interference incident during a training exercise, where her manual navigation predictions had proven accurate while GPS systems failed, she found herself removed from the primary aircrew rotation that governed flight assignments across the squadron. Her name disappeared from the mission scheduling board in the operations center, replaced by a notation that read, "Special Assignment Training Evaluation Pending." Major Coleman delivered this news during what was ostensibly a routine performance review meeting, her tone carefully modulated to suggest administrative necessity rather than punitive action. The phrase training evaluation had become institutional code for quarantining personnel whose methods contradicted established modernization policies. Chief Martinez, Command has decided to reassign you to aircraft systems evaluation duties while we review navigation training protocols following recent exercise complications, Coleman explained, consulting her tablet where she maintained notes about personnel management decisions. This temporary measure ensures optimal crew integration and allows us to assess how traditional navigation methods fit within contemporary operational frameworks. The term exercise complications had become the official euphemism for the GPS system failures that Rebecca had accurately predicted 3 days before they occurred. Rather than acknowledging her expertise, the command structure had chosen to treat her warning as somehow contributing to the problem itself. The twisted logic suggested that if she hadn't raised concerns about satellite navigation vulnerabilities, the aircrew might have approached the exercise with more confidence and achieved better results. Rebecca's new duties involved conducting solo evaluation flights on aircraft returning from major maintenance, essentially serving as a test pilot for repairs and modifications that didn't require the attention of aircrew flying operationally significant missions. While this work was technically important for ensuring aircraft safety, it effectively isolated her from the squadron's primary activities and eliminated any opportunity for her to demonstrate her navigation capabilities in challenging scenarios that might validate her traditional techniques. The first aircraft assigned for her evaluation testing was a C-130 Hercules that had undergone avionics upgrades designed to improve GPS navigation accuracy and satellite communication reliability. The maintenance work was routine, but regulations required a qualified aircrew member to verify that all systems functioned properly before the aircraft could return to active duty status. Rebecca approached the evaluation flight with characteristic thoroughness, but her detailed findings created additional friction with maintenance personnel who viewed her standards as unnecessarily demanding. Her post-flight report documented 3 areas of concern that fell within acceptable parameters, but represented potential problems that could worsen without proper attention. The GPS navigation system showed intermittent signal acquisition delays during startup sequences. The satellite communication equipment experienced brief connection interruptions when switching between frequency bands, and the flight management computer displayed minor calculation inconsistencies when processing route modifications during flight operations. Bays. Chief Master Sergeant William Parker, who supervised aircraft maintenance operations across the base, reviewed Rebecca's report with obvious reluctance and growing irritation. Her findings would require additional work hours and parts procurement that would complicate his maintenance schedules and budget projections. Parker had built his reputation on efficiency metrics that emphasized quick aircraft turnaround times, rather than the exhaustive inspection standards that Rebecca's experience had taught her to maintain. Chief Martinez, these issues are all within normal tolerances according to technical specifications, Parker explained with the patience of someone addressing an unreasonably demanding customer. The aircraft meets all safety requirements and operational readiness standards. Your concerns about minor performance variations don't justify delaying this bird's return to flight status when we have higher priority maintenance requirements demanding our attention. Rebecca studied the technical data that supported Parker's assessment while understanding that minimum acceptable performance and optimal operational capability represented significantly different standards. Her experience had taught her that minor problems often indicated developing issues that could affect mission effectiveness if left unaddressed, particularly when aircraft were operating in challenging environments where system reliability became critical for crew safety and mission success. Chief Parker, these symptoms suggest potential degradation in satellite navigation reliability, Rebecca replied, pointing to specific data points in her evaluation report. The signal acquisition delays could become more severe in polar regions where GPS coverage is naturally limited, and the communication interruptions might indicate antenna alignment problems that could affect emergency coordination capabilities. Parker's expression reflected his frustration with what he perceived as perfectionist demands that complicated efficient maintenance operations. His responsibilities included maintaining dozens of aircraft on strict schedules that allowed minimal time for addressing issues that didn't represent immediate safety hazards. Rebecca's attention to detail was creating additional work requirements that threatened to disrupt carefully planned maintenance cycles designed to maximize aircraft availability for operational missions. The conversation exemplified a broader institutional conflict between Rebecca's experience-based standards and the efficiency-focused policies that had shaped modern military maintenance operations. Her traditional approach emphasized preventing problems before they became critical, while contemporary procedures focused on addressing only those issues that exceeded specific threshold parameters. The difference in philosophy reflected competing priorities between operational readiness and administrative efficiency. Captain Walsh became increasingly vocal in her criticism of what she characterized as Rebecca's disruptive perfectionism during informal conversations with other aircrew members. These discussions typically occurred in the squadron ready room, where pilots and aircrew gathered between missions to review flight plans, discuss operational issues, and maintain the social bonds that characterized military aviation culture. Walsh's complaints about Rebecca's evaluation standards created an atmosphere of professional isolation that made her presence in common areas increasingly uncomfortable. Chief Martinez wants every aircraft rebuilt to factory specifications before she'll sign off on evaluation flights, Walsh complained to a group of younger aircrew members during one such gathering. Yesterday, she grounded a perfectly functional C-130 because of GPS signal delays that lasted maybe 3 seconds longer than optimal. At this rate, we'll never have enough aircraft available for actual mission requirements because she's too paranoid about minor technical variations. These conversations always seemed to occur when Rebecca was present but not directly included in the discussion, creating a social dynamic that emphasized her exclusion from the informal networks that shaped squadron culture and professional relationships. The younger aircrew would nod sympathetically while glancing in her direction, reinforcing the message that her standards and methods were considered problematic by the squadron's emerging leadership generation. Technical Sergeant Kim had begun organizing study groups focused on advanced GPS navigation techniques and satellite communication procedures that explicitly excluded aircrew who weren't current on the latest equipment configurations. These informal training sessions took place during off-duty hours at locations away from the base, creating professional development opportunities that were available only to personnel who embraced modern navigation methods while systematically excluding those who maintained traditional skills. The social ostracism extended to professional development opportunities that could affect career advancement and operational assignments. Advanced training courses, technical conferences, and specialized certification programs were increasingly allocated to aircrew who demonstrated proficiency with modern navigation systems while being denied to those whose expertise included manual techniques that were characterized as obsolete and irrelevant to contemporary operational requirements. When Rebecca submitted a request to attend the Advanced Navigation Techniques Symposium at the Air Force Institute of Technology, Major Coleman rejected the application with an explanation that reflected the institutional bias against traditional navigation methods. The symposium focused primarily on satellite-based navigation systems and digital communication protocols that required current certification on modern avionics equipment for meaningful participation in the technical discussions. Chief Martinez, this conference emphasizes integration with satellite navigation systems and computerized flight planning tools that align with your current aircraft assignment, Coleman explained during their meeting to discuss professional development opportunities. Since your evaluation duties focus on basic aircraft systems rather than advanced navigation applications, the training wouldn't provide direct benefits for your present responsibilities and might create confusion about operational priorities. The reasoning was technically accurate but professionally devastating for Rebecca's career development prospects. Her exclusion from advanced training was justified by her assignment to aircraft evaluation duties, while her assignment to evaluation duties was justified by her focus on traditional navigation techniques rather than modern systems. The circular logic created an inescapable professional trap that ensured her continued marginalization regardless of her actual capabilities or potential contributions to squadron effectiveness. Even her physical workspace reflected her diminished status within the squadron organization. Rebecca's assigned desk in the aircrew ready room was relocated to a corner position where she could observe ongoing activities, but couldn't easily participate in the informal discussions that shaped operational planning and crew coordination. Her name was removed from the duty roster displays and mission assignment boards that tracked aircrew availability and qualification status. The administrative isolation was accompanied by systematic erosion of her operational responsibilities and decision-making authority. Flight authorization requests that had previously been processed automatically now required additional approvals and documentation that created bureaucratic delays for any activities involving traditional navigation techniques. Mission proposals that included manual navigation components were consistently returned with requests for alternative approaches that emphasized technological solutions over individual expertise. When Rebecca proposed conducting advanced maneuvering training using manual navigation techniques to maintain her proficiency for potential emergency situations, Lieutenant Colonel Torres rejected the request based on resource optimization and safety considerations. His written response noted that solo training flights in older aircraft created unnecessary maintenance expenses without contributing to squadron operational capabilities or advancing institutional modernization objectives. The message was unmistakably clear. Rebecca's navigation skills were no longer considered valuable enough to justify the costs associated with maintaining her proficiency. Her decades of experience successfully guiding aircraft across global distances using traditional techniques were being treated as expensive indulgences rather than strategic assets that might prove essential when technological systems encountered operational conditions that exceeded their design parameters. Her performance evaluations began reflecting this institutional bias with bureaucratic precision that made discrimination appear objective and professionally justified. While her technical ratings remained consistently high in traditional categories, new evaluation criteria had been introduced that systematically scored her poorly in areas that emphasized technological adaptation and integration with modern navigation systems rather than fundamental aviation skills and experience. The evaluation comments were particularly insidious in their combination of faint praise with subtle criticism that painted her expertise as a professional liability rather than a valuable asset. Her supervisors noted her exceptional technical knowledge and superior manual navigation skills, while simultaneously questioning her adaptability to contemporary operational environments and her willingness to embrace institutional modernization initiatives that prioritize technological solutions over traditional methods. Rebecca's professional isolation reached its nadir when she discovered that her security clearance had been flagged for routine review, a bureaucratic process that effectively suspended her access to classified mission planning materials and operational intelligence briefings. The review was ostensibly standard procedure for personnel with extensive overseas deployment history, but the timing coincided suspiciously with her continued advocacy for manual navigation training and her criticism of over-reliance on satellite systems. Without access to classified briefing materials, Rebecca could no longer participate in mission planning sessions that required knowledge of sensitive flight routes, threat assessments, or operational objectives that govern squadron activities. Her exclusion from these briefings was presented as a temporary administrative measure, but it effectively eliminated her from any meaningful involvement in the squadron's operational planning process, while maintaining the appearance of following established security protocols. Master Sergeant Hayes delivered the news during a private meeting in his office, his expression reflecting the discomfort of someone required to implement policies he didn't necessarily support. Hayes had worked with Rebecca for over 3 years and understood her professional competence and dedication, but his position as senior enlisted advisor required him to enforce command decisions regardless of his personal opinions about their fairness or wisdom. Chief Martinez, this security review is completely routine and shouldn't reflect on your professional standing or operational qualifications, Hayes explained while handing her the official notification documents. The process typically takes 4 to 6 weeks to complete, during which time you'll be restricted to non-classified duties and training activities. Once the review concludes, your full access should be restored automatically. Rebecca understood the implications immediately. 6 weeks without access to classified materials would effectively remove her from any operational missions that required security clearances, further limiting her duties to routine aircraft evaluation and basic training activities that didn't require knowledge of sensitive operational information. The timing would also prevent her from participating in the squadron's upcoming deployment preparation exercises that were scheduled to begin within the month. The security review represented another layer of bureaucratic isolation that complemented the administrative and social exclusion she had already experienced. Command could maintain that her treatment was based on standard procedures and security requirements rather than discriminatory policies, while achieving the practical effect of completely marginalizing her professional contributions to squadron operations. Captain Morrison had been assigned as acting crew chief for Rebecca's former aircraft during her security review period, a temporary arrangement that was described as maintaining operational readiness while she completed administrative requirements. Morrison's appointment represented a significant departure from normal protocols, since he lacked the experience and qualifications that typically governed crew chief assignments for complex transport aircraft operations. Morrison's approach to aircraft inspection and maintenance oversight differed dramatically from Rebecca's meticulous standards. Where she had conducted exhaustive pre-flight examinations that often identified minor problems before they became serious issues, Morrison relied primarily on computerized diagnostic systems and maintenance reports that focused on major component status rather than subtle performance indicators that might suggest developing problems. His first evaluation flight in Rebecca's former aircraft resulted in a perfunctory inspection report that noted no significant discrepancies, despite several minor issues that Rebecca's experience would have flagged for further investigation. The GPS navigation system continued to show intermittent signal acquisition delays, the satellite communication equipment experienced occasional frequency drift, and the flight management computer displayed calculation inconsistencies that suggested potential software problems. Chief Parker welcomed Morrison's less demanding inspection standards with obvious relief, appreciating an aircrew member who focused on major safety issues rather than the perfectionist attention to detail that had characterized Rebecca's evaluation reports. Morrison's willingness to accept aircraft performance within established tolerance ranges reduced maintenance workload and simplified scheduling decisions that had been complicated by Rebecca's insistence on addressing minor problems before they affected operational capability. Captain Morrison understands that we're operating under resource constraints and schedule pressures that require practical decision-making about aircraft readiness, Parker explained to his maintenance supervisors during their weekly planning meeting. Unlike some aircrew members who demand perfection in every system, Morrison recognizes that minor performance variations are acceptable as long as aircraft meet basic safety requirements and operational specifications. The comparison was clearly directed at Rebecca's evaluation standards, even though Parker avoided mentioning her by name. His comments reflected the institutional preference for efficiency over thoroughness that had shaped maintenance policies across the squadron, prioritizing quick aircraft turnaround times over the comprehensive inspection procedures that Rebecca's experience had taught her to value. Rebecca's exclusion from operational briefings meant that she learned about squadron activities through informal conversations and public announcements rather than direct participation in planning processes. She discovered that the squadron was preparing for a major Arctic training exercise involving coordination with Canadian and Scandinavian air forces during challenging winter weather conditions that would test navigation capabilities under some of the most demanding circumstances military aircrew could encounter. The exercise would require flying routes over polar regions where GPS satellite coverage was naturally limited by orbital mechanics, where magnetic compass navigation was complicated by proximity to magnetic pole variations, and where electromagnetic interference from aurora activity could disrupt satellite communication systems. These conditions represented exactly the operational challenges that Rebecca's manual navigation expertise was designed to address. Lieutenant Chen had been selected to serve as primary navigator for the exercise, her appointment based on her advanced academic credentials in satellite navigation systems and her high scores on computer-based navigation proficiency examinations. Chen's theoretical knowledge of GPS operations and digital communication protocols made her an obvious choice for missions that emphasize technological integration and automated navigation procedures. However, Chen's practical experience was limited to flights in benign weather conditions with reliable satellite coverage and minimal electromagnetic interference. She had never navigated using manual techniques during GPS system failures, never calculated wind drift corrections without computer assistance, and never plotted courses using paper charts and magnetic compass headings. Her qualifications were impressive on paper, but untested under the harsh conditions that characterized Arctic flying operations. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. The exercise planning sessions that Rebecca could no longer attend focused heavily on GPS navigation procedures and satellite communication protocols, while giving minimal consideration to backup navigation methods that might become necessary if electronic systems encountered problems. The mission planners assumed that modern avionics would provide adequate reliability despite the challenging electromagnetic environment and limited satellite coverage that characterized polar regions. Rebecca's quarters became her refuge from the professional isolation that had engulfed her squadron activities. Her small apartment off base contained a personal library of navigation texts, technical manuals, and historical accounts of Arctic flying operations that spanned the entire development of military aviation. She spent her evenings studying these materials and maintaining the navigation skills that her colleagues had dismissed as obsolete. Her collection included detailed charts of polar regions with magnetic variation data, celestial navigation tables for astronomical position fixing, and wind pattern analyses that showed seasonal variations in Arctic weather systems. These resources represented decades of accumulated knowledge about navigation challenges that couldn't be addressed through satellite technology alone, information that remained relevant despite the widespread adoption of GPS systems. The apartment's walls displayed photographs from her deployment history showing aircraft operations in remote locations around the world, where navigation challenges had required the traditional techniques that younger aircrew had never learned. Images of C-17 operations in Afghanistan, humanitarian missions in Africa, and strategic airlift flights across the Pacific provided visual reminders of the diverse operational environments where manual navigation skills had proven essential for mission success. Rebecca maintained a private training regimen that preserved her proficiency with traditional navigation techniques despite the lack of official support for such activities. Using commercially available flight planning software, she practiced plotting courses across polar regions, calculating fuel requirements for extended flights over areas without emergency landing fields, and developing contingency plans for navigation system failures that might occur during critical mission phases. Her training scenarios included realistic problems that combined multiple system failures with adverse weather conditions, creating navigation challenges that required traditional techniques for successful resolution. She practiced astronomical navigation using star charts and sextant calculations, dead reckoning navigation using time and distance measurements, and magnetic compass navigation corrected for polar region variations that could confuse aircrew who relied entirely on GPS systems. The maintenance technicians who had worked with Rebecca during her operational flying period occasionally sought her advice about aircraft problems that weren't clearly addressed by technical manuals or diagnostic procedures. These informal consultations occurred away from official channels, since seeking guidance from someone who was technically assigned to evaluation duties rather than operational flying could be viewed as questioning established maintenance protocols. Sergeant Rodriguez, an experienced avionics technician, approached Rebecca privately about intermittent GPS navigation problems that had affected several aircraft but hadn't been resolved through standard troubleshooting procedures. The issues occurred primarily during flights in certain geographical regions where electromagnetic interference seemed to disrupt satellite signal reception, creating navigation errors that were inconsistent and difficult to reproduce during ground testing. Chief Martinez, "We're seeing GPS accuracy problems that don't match any known failure patterns," Rodriguez explained during a conversation in the base maintenance facility. "The systems pass all diagnostic tests, but aircrew report position errors during flights over specific areas. Standard procedures don't address this kind of intermittent problem, and the technical manuals assume that GPS failures would be obvious and consistent." Rebecca's understanding of electromagnetic interference patterns and satellite signal propagation allowed her to explain the technical factors that were causing the navigation problems Rodriguez had described. The issues resulted from atmospheric conditions that created signal reflection and multipath errors rather than complete GPS system failures, producing subtle navigation inaccuracies that computerized diagnostic systems couldn't detect during ground testing. Her explanation provided Rodriguez with the technical understanding necessary to develop more effective troubleshooting procedures, but their consultation had to remain unofficial since Rebecca's current assignment status didn't include responsibility for operational navigation systems. The conversation reflected the gap between institutional policies that emphasized modern navigation systems and the practical reality that traditional navigation expertise remained valuable for solving complex technical problems. These private consultations reminded Rebecca that her knowledge and experience retained practical value despite the official dismissal of manual navigation techniques. Her understanding of navigation principles that transcended specific technological implementations allowed her to analyze problems that confused technicians who had learned to operate sophisticated systems without necessarily understanding the underlying physics and mathematics that made navigation possible. The crisis erupted at 0347 hours on a Tuesday morning, when the emergency klaxon pierced the pre-dawn quiet at McCord Air Force Base, followed immediately by the urgent voice of Master Sergeant Hayes broadcasting over the squadron communication system. His normally calm demeanor had been replaced by barely controlled urgency as he announced that Tactical Fighter Squadron 42, consisting of 4 F-22 Raptor stealth fighters, had missed their scheduled communication check during a routine training mission over the Alaskan wilderness. All available aircrew report to operations immediately, Hayes transmitted across the base-wide frequency. We have 4 Raptors, approximately 6 hours overdue for contact, last known position over the Denali region. Weather conditions are deteriorating rapidly with complete cloud cover, severe electromagnetic interference and visibility approaching zero throughout the search area. Lieutenant Colonel Torres emerged from his quarters within minutes, his expression reflecting the kind of controlled alarm that accompanied genuine emergencies involving missing aircraft and aircrew. The F-22 Raptor represented the most advanced fighter aircraft in the Air Force inventory, equipped with stealth technology, sophisticated navigation systems, and communication equipment that should have made losing contact virtually impossible under normal circumstances. The missing squadron had departed Elmendorf Air Force Base near Anchorage 18 hours earlier for what was planned as a routine navigation training exercise over the Alaskan interior. The mission parameters included practicing formation flying, navigation coordination, and communication procedures in the challenging electromagnetic environment that characterized polar regions during periods of high aurora activity. Their planned route would take them over some of the most remote and inhospitable terrain in North America. Captain Walsh arrived at the operations center still wearing her flight suit from the previous day's mission, her expression showing the kind of focused concern that characterized professional aviators facing a potential aviation disaster. The missing F-22s carried pilots from the 525th Fighter Squadron, colleagues she had worked with during joint training exercises and deployment preparations. The possibility that 4 experienced pilots might be lost over the Alaskan wilderness created a sense of urgency that transcended normal operational procedures. The initial briefing revealed the scope of the challenge facing any potential search and rescue operation. The last communication from Raptor flight had occurred over the Denali National Park region, an area encompassing thousands of square miles of mountainous terrain with limited emergency landing options and virtually no ground-based navigation aids. The pilots had reported encountering severe weather conditions that were forcing them to deviate from their planned route to avoid dangerous icing and turbulence. Major Coleman stood before a large tactical display showing the vast search area where the missing aircraft might be located, her expression reflecting the mathematical complexity of the challenge they faced. The F-22s had sufficient fuel capacity to fly several hundred miles in any direction from their last known position, creating a search area that would require dozens of aircraft operating for days to cover comprehensively using conventional visual search methods. Satellite imagery is completely useless due to cloud cover, Coleman explained, pointing to weather maps that showed solid overcast conditions extending across the entire region. GPS tracking of the Raptors has been intermittent due to electromagnetic interference from aurora activity, and we've lost all communication contact. Standard search and rescue aircraft, equipped with modern navigation systems, are reporting significant difficulties operating in the current atmospheric conditions. The electromagnetic interference that had disrupted communication with the missing F-22s was also affecting the navigation systems of potential rescue aircraft. Several C-130 search planes had attempted to reach the area, but had been forced to return to base after experiencing GPS failures, communication blackouts, and navigation system malfunctions that made safe flight operations impossible under the challenging weather conditions. Captain Chen, who had been designated as primary navigator for potential rescue operations based on her advanced training with satellite navigation systems, stood before computer displays showing the chaos that electromagnetic interference was creating throughout the region. Her sophisticated navigation equipment was generating false position readings, satellite communication systems were experiencing complete signal loss, and the digital flight management computers were producing calculation errors that made automated navigation unreliable. Every GPS-dependent aircraft we've sent toward the search area has encountered system failures within 30 minutes of reaching the electromagnetic interference zone, Chen reported, her voice reflecting frustration with the inadequacy of her technological expertise when faced with natural phenomena that overwhelmed electronic systems. Our most advanced navigation equipment is essentially useless under current atmospheric conditions. The failure of modern navigation systems to function effectively in the electromagnetic environment created by aurora activity represented exactly the scenario that traditional navigation advocates had warned could occur. The sophisticated satellite-dependent systems that had replaced manual navigation techniques were proving inadequate when natural phenomena disrupted the electronic infrastructure that modern aviation had come to depend upon completely. Technical Sergeant Kim attempted to coordinate with civilian search and rescue authorities, but discovered that commercial aviation was experiencing similar problems with navigation system reliability in the affected region. Airlines had canceled flights over Alaska, emergency medical helicopters were grounded due to navigation equipment failures, and even ground-based GPS systems were providing erratic position information that made coordinate rescue efforts virtually impossible. The scope of the electromagnetic interference exceeded anything that had been recorded in recent decades, creating navigation challenges that the architects of modern aviation systems had not anticipated when designing satellite-dependent navigation protocols. Aurora activity was generating electromagnetic fields that were disrupting GPS satellites, interfering with radio communications, and creating compass variations that made magnetic navigation unreliable even for aircraft equipped with traditional backup systems. Lieutenant Colonel Torres faced the kind of command decision that would define his career and potentially determine whether 4 pilots lived or died in the Alaskan wilderness. His most advanced aircraft were unable to operate effectively in the search area due to navigation system failures that their sophisticated computers couldn't overcome. The F-22s that he needed to find were equipped with the same satellite-dependent systems that were failing on his rescue aircraft. "Sir, we need to consider alternatives to conventional search methods," suggested Master Sergeant Hayes, whose experience included search and rescue operations during earlier decades when electronic navigation was less sophisticated. The electromagnetic interference is affecting all satellite-dependent systems, but manual navigation techniques might still be effective for aircraft that don't rely entirely on GPS and digital communications. The suggestion represented a fundamental challenge to the technological assumptions that had shaped modern Air Force operations. Hayes was essentially recommending that they abandon their most advanced aircraft and navigation systems in favor of traditional techniques that the institution had largely eliminated from operational procedures. The implications were professionally and politically dangerous for commanders who had built their careers on embracing technological modernization. Colonel James Patterson, the base commander, joined the emergency briefing via secure video link from his temporary assignment at the Pentagon, his expression reflecting the gravity of a situation that could result in the loss of 4 irreplaceable F-22 aircraft and their highly trained pilots. Patterson had been following the search efforts remotely and understood that conventional rescue methods were proving inadequate for the current emergency. "What aircraft do we have available that might be capable of operating independently of GPS navigation?" Patterson asked, cutting directly to the practical question that everyone in the room was avoiding. "We need to locate those Raptors before their fuel reserves are exhausted, or emergency survival becomes the primary concern for their pilots." The question forced acknowledgement of an uncomfortable reality that the Air Force had systematically eliminated most aircraft and personnel capable of operating effectively without satellite navigation assistance. The institutional commitment to technological modernization had created a vulnerability that was now being exposed by natural phenomena that exceeded the design parameters of modern navigation systems. Bees. Major Coleman consulted her aircraft availability reports, searching for options that might provide navigation capability independent of the satellite systems that were failing throughout the electromagnetic interference zone. Most of the squadron's aircraft were equipped with GPS-dependent navigation systems that required satellite connectivity for effective operation, leaving few alternatives for missions that needed to function without electronic assistance. Staff Sergeant Santos had been monitoring communication frequencies used by search and rescue aircraft, documenting the consistent pattern of navigation failures that had forced multiple rescue attempts to abort their missions. Her reports showed that every aircraft equipped with modern avionics had experienced significant problems when operating in the electromagnetic interference zone, while older aircraft with analog systems had maintained basic navigation capability. Sir, we have reports from Canadian search authorities that aircraft using traditional navigation methods have been able to maintain limited operations in the affected area, Santos reported. Their older aircraft equipped with magnetic compass navigation and visual reference techniques have achieved some success in conducting search patterns, although weather conditions are severely limiting visibility for ground observation. The information suggested that manual navigation techniques might provide the operational capability that satellite-dependent systems could not deliver under current atmospheric conditions. However, implementing traditional navigation methods would require aircrew qualified in techniques that the Air Force had largely abandoned in favor of technological solutions that were now proving inadequate for the emergency they faced. Torres turned toward the corner of the operations center where Rebecca Martinez sat quietly, having been summoned to the emergency briefing despite her exclusion from normal operational planning. Her presence had been required because regulations mandated that all available aircrew report during aircraft emergency situations, but she had not been included in the planning discussions that had focused on technological solutions to the navigation challenges. The moment that everyone in the room had been avoiding had finally arrived. The pilot, whose traditional navigation skills had been systematically dismissed as obsolete, was suddenly the only person on the base who possessed the expertise necessary to succeed where modern technology had failed completely. The electromagnetic interference that was defeating their most advanced systems was precisely the operational challenge that manual navigation techniques had been designed to address. The operations center fell into an uncomfortable silence as Lieutenant Colonel Torres realized that his most technologically advanced aircrew were helpless against the electromagnetic interference that had already defeated multiple rescue attempts. Every GPS-dependent aircraft had been forced to abort their missions, communication systems were experiencing complete blackouts, and the sophisticated navigation equipment that defined modern Air Force operations was proving useless when confronted with natural phenomena that exceeded design parameters. Torres found himself staring across the room at Rebecca Martinez, the woman whose traditional navigation warnings had been dismissed as outdated paranoia just weeks earlier. Her quiet presence in the corner of the operations center represented an uncomfortable reminder that institutional faith in technological solutions had created exactly the vulnerability she had predicted would eventually threaten mission success and aircrew safety. "Chief Martinez," Torres said carefully, his voice carrying the weight of command responsibility mixed with personal reluctance to acknowledge that conventional wisdom had proven catastrophically wrong. "You've been monitoring the situation. What's your assessment of our navigation challenges in the current electromagnetic environment?" Rebecca stood from her corner position, moving toward the tactical displays that showed the vast search area where 4 F-22 pilots were running out of time and fuel while sophisticated rescue aircraft remained grounded by system failures. Her expression reflected professional composure rather than satisfaction at being vindicated, understanding that 4 lives were more important than settling institutional scores about navigation philosophy. "Sir, the Aurora activity is generating electromagnetic fields that are disrupting GPS satellite signals, interfering with radio communications, and creating compass variations that affect magnetic navigation," Rebecca explained, pointing to specific areas on the weather maps where electromagnetic interference was most severe. "Modern avionics systems are particularly vulnerable because they depend on satellite connectivity and digital processing that can be overwhelmed by electromagnetic noise." Major Coleman interrupted with obvious skepticism, her institutional commitment to technological solutions making it difficult to accept that modern systems could be so completely defeated by natural phenomena. "Chief Martinez, our navigation equipment includes backup systems and error correction algorithms specifically designed to function during electromagnetic interference. The probability of simultaneous failure across multiple independent systems approaches 0 under any reasonable scenario." Rebecca turned toward Coleman with the patience of someone who had tried repeatedly to explain these concepts to colleagues who preferred theoretical assurances over practical experience. Major electromagnetic interference doesn't cause system failures in the traditional sense. It creates signal degradation, false readings, and calculation errors that sophisticated computers interpret as valid data. The backup systems you're describing all depend on the same satellite infrastructure that's being disrupted by atmospheric conditions. Captain Walsh joined the discussion, her expression reflecting the growing desperation of someone watching colleagues disappear into one of the most hostile environments on Earth while their most advanced rescue capabilities proved inadequate. Chief Martinez, assuming you're correct about GPS vulnerabilities, what alternatives do we have for conducting search operations in zero-visibility conditions over thousands of square miles of wilderness terrain? The question represented the first genuine request for Rebecca's expertise that she had received in months, marking a significant shift from the dismissive attitudes that had characterized previous interactions with Squadron leadership. The emergency had created conditions that forced acknowledgement of traditional navigation value, despite institutional policies that had systematically marginalized such expertise. Rebecca moved to the paper charts that covered one wall of the operations center, maps that showed topographical details, magnetic variation data, and geographical reference points that remained accurate regardless of satellite availability. Her fingers traced potential search patterns that could be flown using visual navigation techniques combined with dead reckoning calculations that didn't require electronic assistance. Manual navigation uses geographical reference points, magnetic compass headings, and time-distance calculations to determine aircraft position and maintain course accuracy, Rebecca explained, plotting routes that avoided the most challenging terrain while maximizing search coverage. These techniques work independently of satellite systems and actually become more reliable than GPS when electromagnetic interference is present. Lieutenant Chen approached the charts with obvious confusion, her training having provided no practical experience with navigation methods that didn't involve satellite coordinates and digital displays. Chief Martinez, how can you possibly maintain position accuracy over hundreds of miles without GPS reference points? Manual calculations can't achieve the precision that satellite navigation provides under normal conditions. Rebecca's response reflected the fundamental difference between technological precision and operational effectiveness that younger aircrew had never been forced to understand. Lieutenant, GPS provides 3-meter accuracy when it's working properly, but 0 accuracy when electromagnetic interference disrupts satellite signals. Manual navigation provides mile-level accuracy under any conditions, which is sufficient for locating missing aircraft and conducting search operations. The mathematical reality was uncomfortable for personnel who had been trained to expect technological perfection rather than practical adequacy. Rebecca's traditional techniques couldn't match the precision of satellite navigation under ideal conditions, but they could provide reliable navigation capability when modern systems failed completely, making them operationally superior during the current emergency. Technical Sergeant Kim studied the manual navigation procedures that Rebecca was describing, struggling to understand how aircrew could maintain situational awareness without the digital displays and computerized calculations that had defined his training experience. Chief Martinez, without GPS coordinates and electronic charts, how would you know where to search for the missing aircraft? The area covers thousands of square miles with similar terrain features. Rebecca pulled out additional charts that showed prevailing wind patterns, fuel consumption calculations, and probability analyses based on the F-22's last known position and estimated fuel reserves. Her approach combined traditional navigation principles with systematic search theory that had guided rescue operations for decades before satellite technology became available. We calculate probable search areas based on the aircraft's last known position, fuel remaining, weather conditions, and pilot behavior patterns, Rebecca explained, marking zones on the charts that represented the most likely locations where the missing F-22s might be found. Then we fly systematic search patterns using visual navigation techniques that can function effectively despite electromagnetic interference. Master Sergeant Hayes had been quietly reviewing Rebecca's manual navigation proposals, his experience including search and rescue operations during earlier decades when electronic systems were less sophisticated. Hayes understood both the capabilities and limitations of traditional techniques, recognizing that Rebecca's approach represented their best option for conducting effective search operations under current atmospheric conditions. Chief Martinez, what aircraft would be suitable for manual navigation search operations? Hayes asked, focusing on the practical requirements for implementing traditional navigation techniques during the current emergency. Most of our transport aircraft depend heavily on GPS systems for basic flight operations, even if they retain backup navigation equipment. Rebecca's answer highlighted another uncomfortable reality about institutional modernization policies that had eliminated traditional navigation capability from most aircraft, while concentrating expertise in a few personnel who were considered professionally obsolete. Sergeant Hayes, we need aircraft with analog instruments, magnetic compass systems, and aircrew qualified in manual navigation techniques. Unfortunately, most of our planes have been upgraded with GPS-dependent systems that become unreliable during electromagnetic interference. The conversation was interrupted by an urgent communication from Canadian search authorities, who had been monitoring the rescue coordination efforts from their operations center in Winnipeg. Squadron leader Patricia McKenzie from the Royal Canadian Air Force provided an update that confirmed Rebecca's assessment of navigation challenges while offering potential assistance that could expand their search capabilities. McCord Operations, this is Winnipeg Rescue Coordination. We have aircraft equipped with traditional navigation systems standing by to assist with search operations, McKenzie transmitted over the secure communication channel. However, our pilots report that electromagnetic interference is affecting even magnetic compass navigation due to aurora-induced variations in magnetic field strength throughout the search area. The Canadian update revealed that even traditional navigation techniques were being challenged by the severity of the electromagnetic interference, creating navigation conditions that exceeded the parameters that most aircrew had ever encountered during their operational experience. The situation required navigation expertise that combined traditional techniques with understanding of electromagnetic effects on compass systems and radio navigation aids. Lieutenant Colonel Torres found himself facing a decision that violated every principle of modern Air Force doctrine while representing their only realistic option for locating the missing F-22 pilots before fuel exhaustion forced emergency survival situations. His most qualified navigators were trained on systems that couldn't function in the current electromagnetic environment, while his most experienced traditional navigator had been systematically excluded from operational missions. Chief Martinez, you're suggesting that we launch search operations using navigation techniques that the Air Force has largely abandoned in favor of satellite-dependent systems, Torres said, his voice reflecting the institutional resistance to acknowledging that technological modernization had created dangerous vulnerabilities. What specific aircraft and crew qualifications would be required for the manual navigation operations you're proposing? Rebecca's response would determine whether the Air Force acknowledged the value of traditional navigation expertise or continued to rely on technological solutions that had already proven inadequate for the current emergency. 4 F-22 pilots were depending on decisions that would either vindicate decades of experience with manual navigation techniques or confirm institutional faith in modern systems, despite their demonstrated failure under challenging conditions. Sir, I can conduct search operations using manual navigation techniques in any aircraft equipped with basic flight instruments and magnetic compass systems, Rebecca replied, her voice carrying the quiet confidence of someone who had successfully navigated aircraft across global distances using traditional methods. The C-17 assigned to my evaluation duties has analog backup instruments that can function independently of GPS systems, and I'm qualified to conduct search operations using visual navigation techniques that electromagnetic interference cannot disrupt. Torres understood that authorizing Rebecca's search mission would represent official acknowledgement that traditional navigation skills retained operational value despite institutional policies that had marginalized such expertise. The decision would also expose the inadequacy of modernization policies that had eliminated critical backup capabilities in pursuit of technological efficiency that proved unreliable when natural phenomena exceeded system design parameters. Lieutenant Colonel Torres stared at the tactical display showing the vast expanse of Alaskan wilderness, where 4 F-22 pilots were rapidly approaching fuel exhaustion, while his most advanced rescue aircraft remained grounded by navigation system failures. The electromagnetic interference that had defeated every technological solution was precisely the scenario that Rebecca Martinez had warned about during training exercises, that command had dismissed as unrealistic paranoia. Chief Martinez, you're requesting authorization to launch a solo search mission using manual navigation techniques in an aircraft that lacks the sophisticated systems we consider essential for search and rescue operations, Torres said, his voice reflecting institutional reluctance to abandon established doctrine despite its proven inadequacy. This represents a significant departure from approved procedures and could expose both you and this command to serious liability if the mission fails. Rebecca approached the operations planning table, where paper charts and manual navigation tools lay alongside the sophisticated computer displays that had proven useless during the current emergency. Her hands moved across the topographical maps with practiced precision, plotting search patterns that could be flown without satellite assistance while maximizing the probability of locating the missing aircraft within their estimated fuel reserves. "Sir, 4 pilots are going to die while we debate procedures," Rebecca replied, her voice carrying the authority of someone who had successfully completed similar missions under challenging conditions. "The C-17 assigned to my evaluation duties has analog instruments that can function during electromagnetic interference, and I have the navigation skills necessary to conduct systematic search operations using traditional techniques that natural phenomena cannot disrupt." Major Coleman stepped forward with obvious alarm, her commitment to technological solutions making it impossible to accept that manual navigation could succeed where modern systems had failed. "Chief Martinez, you're proposing to fly alone into severe weather conditions using navigation techniques that haven't been operationally employed for decades. Even if you locate the missing aircraft, you lack the communication equipment necessary to coordinate rescue efforts with other agencies." Rebecca's response highlighted the fundamental misunderstanding about traditional navigation capabilities that had shaped institutional policies favoring technological dependence over individual expertise. Major manual navigation techniques have guided aircraft successfully through Arctic conditions since the 1940s. These methods don't become obsolete simply because newer technology is available, and they actually become more reliable than GPS when electromagnetic interference is present. Captain Walsh joined the discussion, her desperation to locate her missing colleagues overriding her previous skepticism about traditional navigation methods. "Chief Martinez, assuming you can navigate effectively without GPS systems, how would you locate specific aircraft in thousands of square miles of wilderness terrain? Visual search operations require precise coordination and systematic coverage that seems impossible without modern navigation aids." The question revealed the extent to which younger aircrew had lost understanding of fundamental search and rescue principles that predated satellite technology. Rebecca's explanation would need to educate them about proven techniques while demonstrating their continued relevance for current operational challenges. Rebecca moved to the large-scale charts that showed geographical features, elevation patterns, and landmark references throughout the search area. Her finger traced potential flight paths that followed terrain features and atmospheric conditions to maximize search effectiveness while maintaining navigation accuracy using visual reference points. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. Search operations use mathematical probability calculations based on aircraft performance, fuel consumption, weather patterns, and pilot decision-making to determine the most likely locations for missing aircraft, Rebecca explained, marking zones on the charts that represented priority search areas. "Then we fly systematic grid patterns using geographical landmarks and compass headings to ensure complete coverage of high-probability regions." Technical Sergeant Kim struggled to comprehend how aircrew could maintain position awareness and search coordination without the digital displays and satellite communications that had defined his operational experience. "Chief Martinez, without GPS tracking and electronic coordination, how would you communicate your search progress to rescue authorities? Manual navigation seems to require isolation from command support that could be dangerous during emergency operations." Rebecca's answer demonstrated the comprehensive nature of traditional navigation training that encompassed communication procedures as well as position determination techniques. "Sergeant Kim, manual navigation includes scheduled position reports using radio communications with ground stations that can triangulate aircraft location through signal direction finding. These methods provide adequate coordination capability while functioning independently of satellite systems." Master Sergeant Hayes had been quietly reviewing the operational requirements for Rebecca's proposed search mission, understanding both the potential benefits and risks associated with abandoning established procedures in favor of traditional techniques. His experience included oversight of search and rescue operations that had successfully employed manual navigation during earlier decades. "Chief Martinez, what specific equipment and preparation would be required for manual navigation search operations in the current electromagnetic environment?" Hayes asked, focusing on practical implementation details rather than theoretical arguments about navigation philosophy. "We need to ensure that traditional techniques can provide reliable results under actual operational conditions." Rebecca's response revealed the depth of preparation that traditional navigation required compared to the automated procedures that characterized modern operations. Sergeant Hayes, manual navigation requires paper charts with magnetic variation data, compass systems independent of electronic interference, timing equipment for dead reckoning calculations, and pilot proficiency with celestial navigation techniques for position verification when visibility permits. The conversation was interrupted by an urgent update from Elmendorf Air Force Base, where search coordination authorities had been monitoring the electromagnetic interference that was affecting rescue operations throughout Alaska. Colonel Sandra Williams, the regional search and rescue commander, provided information that confirmed the severity of navigation challenges while highlighting the urgency of the missing pilot situation. McCord Operations, this is Elmendorf SAR Control, Williams transmitted over the secure emergency frequency. We've confirmed that all GPS-dependent aircraft in the affected region are experiencing navigation failures. The missing F-22s have been out of contact for over 8 hours, and weather conditions are deteriorating rapidly. We need immediate deployment of any aircraft capable of operating independently of satellite navigation systems. The update from regional headquarters provided official confirmation that conventional rescue methods had failed completely, creating conditions that demanded alternative approaches regardless of institutional preferences for modern navigation systems. Colonel Williams' request essentially authorized employment of any available techniques that might succeed where technological solutions had proven inadequate. Lieutenant Colonel Torres faced the moment of decision that would define his command philosophy and potentially determine whether 4 highly trained pilots survived their emergency in the Alaskan wilderness. His choice between institutional doctrine and operational effectiveness would be scrutinized by senior leadership and could influence Air Force navigation policies for decades to come. Chief Martinez, I'm authorizing your search mission with the understanding that you'll be operating outside established procedures using navigation techniques that haven't been employed operationally for years, Torres announced, his voice reflecting both desperation and reluctant recognition of traditional navigation value. You'll have complete authority to conduct search operations as you determine appropriate, but you'll also bear full responsibility for mission outcomes. Rebecca acknowledged the authorization while understanding that success would vindicate traditional navigation expertise, while failure would confirm institutional prejudices against manual techniques and potentially end her military career. The mission represented more than a search and rescue operation. It was a test of whether individual skill could triumph over technological dependence when natural phenomena exceeded system design parameters. Sir, I'll depart within 30 minutes using the C-17 assigned to my evaluation duties, Rebecca replied, moving toward the equipment storage area where her personal navigation tools waited. I'll maintain scheduled radio contact with search coordination authorities and provide position reports using traditional communication procedures that function independently of satellite systems. Captain Chen approached Rebecca with obvious confusion about the navigation procedures she was proposing to employ during the search mission. Chief Martinez, could you explain how manual navigation techniques would actually work during search operations? My training provided no practical experience with non-GPS navigation methods. Rebecca's explanation would serve as an impromptu lesson in traditional navigation principles for aircrew who had never learned techniques that remained essential when technological systems failed. Lieutenant Chen, manual navigation uses magnetic compass headings corrected for local variation, dead reckoning calculations based on time and airspeed, and geographical landmark recognition to maintain position awareness. These techniques provide reliable navigation capability regardless of electromagnetic interference. Staff Sergeant Santos began gathering communication equipment and emergency supplies that would support Rebecca's solo search mission, her actions reflecting acceptance that traditional methods represented their best hope for locating the missing pilots. Chief Martinez, what backup procedures should we establish for maintaining contact during your search operations? Communication systems are also experiencing interference problems. Rebecca's answer demonstrated the comprehensive nature of traditional navigation training that included contingency planning for communication failures as well as navigation system problems. Sergeant Santos, I'll establish scheduled radio contact every 30 minutes using multiple frequencies to ensure communication reliability. If radio contact fails, I'll return to base at predetermined times to provide search updates and coordinate continued operations. The pre-flight preparation for Rebecca's search mission proceeded with unusual urgency as Squadron personnel gathered navigation equipment, survival gear, and communication devices that would support operations independent of the satellite systems that had failed throughout the region. Her C-17 aircraft underwent rapid inspection to verify that analog instruments and magnetic compass systems were functioning properly. Chief Parker supervised the aircraft preparation with grudging acknowledgement that Rebecca's attention to detail during previous evaluation flights had identified exactly the kinds of minor problems that could become critical during emergency operations. Chief Martinez, all analog navigation systems are functioning within normal parameters, and backup communication equipment has been installed and tested. Rebecca completed her manual navigation planning using paper charts, mathematical calculations, and probability analyses that determined optimal search patterns based on the missing aircraft's last known position and estimated fuel reserves. Her preparation included celestial navigation tables for position verification, magnetic variation corrections for compass accuracy, and alternate route planning for contingency situations. Hewan. As she walked toward her aircraft, Rebecca carried the hopes of 4 missing pilots and the burden of proving that traditional navigation skills retained operational value, despite institutional policies that had systematically eliminated such expertise from modern Air Force operations. Her mission would demonstrate whether individual competence could overcome technological dependence when natural phenomena exceeded the capabilities of sophisticated systems. The electromagnetic interference that had defeated every modern navigation system was about to encounter the one person on McCord Air Force Base who possessed the knowledge and skills necessary to succeed where advanced technology had failed completely. Rebecca Martinez was finally being trusted with a mission that matched her capabilities, and 4 lives depended on her ability to prove that experience and traditional expertise could triumph when computers and satellites could not. Rebecca's C-17 Globemaster lifted off from McCord Air Force Base at 0623 hours, climbing into the gray pre-dawn sky while every other rescue aircraft remained grounded by navigation system failures that had proven insurmountable for crews trained exclusively on satellite-dependent technology. The electromagnetic interference that had defeated the Air Force's most sophisticated systems was invisible to her analog instruments, which responded with mechanical precision to her control inputs, as she established a magnetic heading toward the Alaskan wilderness, where 4 F-22 pilots were approaching their survival limits. Her navigation began with fundamental techniques that predated satellite technology by decades. Using a magnetic compass corrected for local variation, she maintained precise headings while calculating wind drift corrections through dead reckoning methods that required only time, distance, and basic mathematics. The paper charts spread across her navigation table showed topographical features, elevation patterns, and geographical landmarks that remained accurate regardless of electromagnetic conditions affecting electronic systems. As the C-17 crossed into Canadian airspace, Rebecca established radio contact with Winnipeg Rescue Coordination using backup communication frequencies that functioned independently of satellite relay systems. Her position reports provided latitude and longitude coordinates calculated through traditional navigation methods, demonstrating accuracy that surprised controllers who had been dealing with GPS failures throughout the region. "Compass rose heavy, this is Winnipeg Rescue," Squadron Leader Mackenzie transmitted, her voice reflecting amazement at receiving reliable navigation data from an aircraft operating in the electromagnetic interference zone. "We've had multiple aircraft abort search missions due to navigation system failures. How are you maintaining position accuracy without GPS reference?" Rebecca's response educated the Canadian controllers about traditional navigation capabilities while maintaining her systematic flight toward the search area. Winnipeg Rescue compass rose heavy, navigating using magnetic compass headings and dead reckoning calculations. Position verified through geographical landmark recognition and celestial navigation when visibility permits. These techniques provide adequate accuracy for search operations regardless of electromagnetic interference. The weather conditions over Alaska challenged even Rebecca's extensive experience with Arctic flying operations. Solid cloud cover extended from the surface to above 20,000 feet, creating instrument meteorological conditions that required precise navigation without visual reference to ground features. Wind speeds exceeded 40 knots with gusting conditions that demanded constant course corrections to maintain accurate headings toward the search area. Rebecca's traditional navigation techniques adapted to these conditions through mathematical calculations that accounted for wind drift, atmospheric variations, and timing adjustments that kept her aircraft on course despite the challenging weather. Her analog instruments provided reliable flight data, while electromagnetic interference continued to disrupt GPS signals and communication systems throughout the region. At 0847 hours, Rebecca reached the search area where the missing F-22s had last been detected before electromagnetic interference had ended all satellite tracking and communication contact. The vastness of the terrain below was staggering, even for someone with extensive experience in remote regions, encompassing thousands of square miles of mountainous wilderness with elevation variations that created dangerous flying conditions in low-visibility weather. Her search pattern followed mathematical probability calculations based on the Raptor's last known position, estimated fuel reserves, and likely pilot decision-making under emergency conditions. Rebecca flew systematic grid patterns using compass headings and timing intervals that ensured complete coverage of high-probability areas while maintaining navigation accuracy through dead reckoning techniques that functioned independently of external electronic assistance. The electromagnetic interference that had defeated modern navigation systems was actually providing Rebecca with valuable information about atmospheric conditions affecting the search area. Aurora activity created visible light phenomena that indicated electromagnetic field strength and direction, helping her understand how natural forces were disrupting satellite signals while confirming that her traditional navigation methods remained unaffected by the interference. During her third search leg, Rebecca spotted a brief reflection of sunlight from a metallic object approximately 12 miles northeast of her position. Banking sharply to investigate while maintaining precise navigation through compass headings and geographical reference points, she descended through the cloud layer to identify what appeared to be aircraft wreckage on a remote mountainside surrounded by terrain that would challenge even experienced survival specialists. The wreckage belonged to one of the missing F-22 Raptors, its distinctive outline visible despite significant impact damage from what appeared to be a controlled crash landing on relatively level terrain near a frozen lake. Rebecca circled the crash site while searching for signs of pilot survival, noting emergency equipment deployment and tracks in the snow that suggested the pilot had survived the impact and was attempting to reach shelter or signal rescue aircraft. Using traditional air-to-ground signaling techniques, Rebecca rocked her wings to indicate her presence, while the F-22 pilot below responded by creating visible signals in the snow using emergency equipment. The communication confirmed pilot survival while establishing that the airman was mobile and attempting to attract rescue attention using methods that predated radio communication technology. Rebecca's emergency radio transmissions on multiple frequencies eventually reached Canadian rescue authorities despite electromagnetic interference that continued to disrupt normal communication channels. Her position reports used latitude and longitude coordinates calculated through traditional navigation methods, providing rescue coordinators with precise location information for organizing ground recovery operations. Winnipeg Rescue Compass Rose Heavy has located one survivor from missing Raptor flight, Rebecca transmitted, providing detailed coordinates and survival status information. Pilot appears mobile and responsive. Crash site accessible by helicopter when weather conditions permit. Continuing search for remaining 3 aircraft based on formation flight procedures and fuel consumption calculations. The successful location of the first missing pilot validated Rebecca's traditional navigation techniques while demonstrating that manual search methods could achieve results that satellite-dependent systems had been unable to provide. Her mathematical approach to search pattern planning had efficiently covered the most probable crash locations, proving that experience-based decision-making retained operational value despite institutional preferences for technological solutions. Rebecca's search for the remaining F-22s required adjusting her probability calculations based on formation flying procedures and the atmospheric conditions that had forced the pilots to deviate from their planned route. Her understanding of fighter aircraft operations suggested that the other 3 Raptors would likely be found within a limited geographical area if they had maintained formation integrity during their emergency descent. Her navigation continued to function flawlessly despite electromagnetic interference that was intensifying as aurora activity increased throughout the morning hours. The analog instruments and magnetic compass systems that guided her search operations remained completely unaffected by the natural phenomena that had rendered sophisticated electronic navigation systems useless for rescue operations. At 1,034 hours, Rebecca located the second F-22 Raptor approximately 18 miles from the first crash site, confirming her analysis of formation flight patterns and emergency procedures that had guided the pilots during their forced landing sequence. The second aircraft showed similar controlled crash characteristics, with evidence of pilot survival and emergency signaling attempts that indicated the airman was awaiting rescue assistance. The third Raptor was discovered 23 minutes later, positioned consistent with Rebecca's calculations about formation spacing and emergency landing procedures that experienced fighter pilots would employ when facing simultaneous navigation system failures and fuel exhaustion. Each successful aircraft location demonstrated the accuracy of traditional navigation techniques and validated the mathematical approach to search operations that younger aircrew had never learned. Rebecca's systematic search methods located the fourth and final F-22 within 2 hours of reaching the search area, achieving complete mission success using navigation techniques that institutional policies had dismissed as obsolete and irrelevant to modern military operations. All 4 pilots had survived their emergency landings and were signaling rescue aircraft using traditional methods that functioned when electronic communication systems failed. Her return navigation to McCord Air Force Base followed the same traditional techniques that had guided her successful search mission, demonstrating continued accuracy and reliability despite electromagnetic interference that persisted throughout the region. Rebecca's position reports provided rescue coordination authorities with precise information about pilot locations, while proving that manual navigation could maintain operational effectiveness under conditions that defeated modern technology. The landing at McCord occurred exactly on schedule according to Rebecca's manual navigation calculations, her C-17 touching down after a mission that had saved 4 lives while exposing fundamental flaws in institutional assumptions about technological superiority over traditional aviation skills. Her success represented vindication of navigation expertise that had been systematically marginalized, despite its demonstrated value for operations when modern systems encountered natural phenomena that exceeded design parameters. Lieutenant Colonel Torres waited on the flight line as Rebecca shut down her engines, his expression reflecting the complex mixture of relief, amazement, and institutional discomfort that accompanied recognition that traditional navigation skills had succeeded, where the Air Force's most advanced technology had failed completely. The rescue mission had proven that individual expertise retained operational value despite organizational policies that prioritized technological dependence over human capability. Major Coleman approached the aircraft with obvious reluctance to acknowledge that manual navigation techniques had achieved results that sophisticated computer systems could not provide under challenging electromagnetic conditions. Her institutional commitment to technological solutions made it difficult to accept that traditional methods could prove superior to modern avionics under any operational circumstances. Captain Walsh emerged from the operations center with communications confirming that Canadian rescue helicopters had successfully reached all 4 F-22 pilots, using the precise coordinates that Rebecca's traditional navigation had provided. The rescue operations were proceeding smoothly despite continued electromagnetic interference that kept GPS-dependent aircraft grounded throughout the region. Rebecca's mission had not only saved 4 lives, but had exposed institutional vulnerabilities that threatened Air Force operational effectiveness when natural phenomena exceeded the capabilities of satellite-dependent navigation systems. Her success using traditional techniques would trigger comprehensive review of policies that had eliminated essential backup capabilities in pursuit of technological modernization that proved unreliable when electromagnetic interference disrupted electronic infrastructure. The woman they had refused to trust with meaningful missions had just completed the most successful search and rescue operation in recent Air Force history, using navigation skills that institutional wisdom had declared obsolete and irrelevant to contemporary military aviation requirements. Her triumph belonged not only to traditional navigation expertise, but to every pilot who understood that true professional competence required mastery of fundamental techniques that transcended specific technological implementations. 6 months later, Chief Master Sergeant Rebecca Martinez stood before a packed auditorium at the Air Force Academy, addressing the largest gathering of military aviators in the institution's history. Her presentation, titled, "When Technology Fails, the Enduring Value of Traditional Navigation," had drawn attendees from across the globe who wanted to understand how manual techniques had succeeded where billions of dollars in advanced systems had failed. The 4 F-22 pilots she had rescued sat in the front row, their presence serving as living testimony to the life-saving value of skills that institutional policies had nearly eliminated. Captain Walsh, now a devoted student of traditional navigation, had become Rebecca's most vocal advocate for integrating manual techniques with modern technology, rather than replacing one with the other. The investigation that followed Rebecca's successful mission had triggered the most comprehensive review of Air Force navigation policies in decades. Lieutenant Colonel Torres had been reassigned to a desk position after his failure to recognize critical capabilities within his own squadron. Major Coleman faced formal reprimand for systematic discrimination that had endangered lives by marginalizing essential expertise. Rebecca's new assignment as Director of Navigation Excellence at the Air Force Institute of Technology included responsibility for developing curriculum that combined traditional skills with modern technology. Her program, mandatory for all military aviators, ensured that future generations would possess backup capabilities that functioned when sophisticated systems encountered their operational limits. The Martinez Protocol, now standard throughout military aviation worldwide, required all aircrew to maintain proficiency in manual navigation techniques alongside their technological training. Her classroom had become a pilgrimage site for pilots, seeking to understand that true mastery meant being better than their aircraft, not dependent on them. What incredible stories of overlooked expertise inspire you most? Have you ever witnessed traditional skills triumph over modern technology? Share your thoughts in the comments below. And don't forget to subscribe for more amazing tales of underdogs who changed everything through determination and forgotten wisdom that saved the day. Babe.